Welcome everybody and thank you for joining the GoEngineer webinar for SOLIDWORKS Electrical Harnesses. My name is Injy Gadalla. I'm an application engineer for Go, and I will go ahead and present today SOLIDWORKS Electrical. So when we talk about signal harness, I first want to just make sure that whoever come in late, this webinar will be recorded and it will be posted on our YouTube channel. So if you sign up for our channel, you will get the notification when it's released. So you can go ahead and play it at any time. Also for questions, you can post them in the questions panel and I will go through those at the end of the webinar so I can get most of your questions answered. If any questions will be remaining, then we'll go ahead and follow up with those. So when we talk about signal harness in Altium Designer, it allows the logical grouping of different but related signals, including buses and wires. The harness is treated as a single entity, which can be used across the whole project and enables for the creation and manipulation of higher-level abstract connections between sub-circuits in your printed circuit boards. But how about the more like interconnection, the higher level, the system level interconnection, when dealing with not only the electronics, but the electrical connection between your different modules or subsystem? How about the cable harnessing? How about your connector drawings, the from-to list, the wires and cable length? This is where SOLIDWORKS Electrical offers a great solution to create wires and cable harnesses. SOLIDWORKS Electrical comes in with two platform. There is the Schematic 2D and there is the 3D add-in to your existing SOLIDWORKS platform. The common electrical design process as an engineer starts by creating your drawing, and that includes your actual drawing, your part selection, and then parts creation. Once this is done, you pass it over to create your documentation. That's including your bill of material, that includes your wires from to list, and also that will be created in a format that can be used and passed on to your procurement department so they can go ahead and audit this information that you presented in an Excel spreadsheet. And then if they find any modification, they will go ahead and pass this over back to you. So as you see, the process goes over and over again, and then there will be a lot of manual checking, and there's no automation between the drawing and the documentation stage. So all of these three stages are manual and again, very vulnerable to many errors. What we offer as SOLIDWORKS Electrical, an easy platform that it's more efficient for your design tools. Also, what it does with SOLIDWORKS Electrical, we fully automate, and these processes, where you spend most of your time, these processes will be automated. The heart of the collaboration exists in the libraries. So we offer a comprehensive library across the 2D and the 3D space that will allow users to create, to search, to modify existing parts. And not only that, the 2D information or the 3D, they're disconnected. Now they're true collaboration between the electrical 2D and the 3D space. Also, your component possesses all the metadata as your single line diagram, multi-line schematic diagram, 3D information, or even panels information. Not only that we can create new parts, but you can also import your symbol drawings into SOLIDWORKS Electrical. So that's kind of really accelerates that process. If you have some drawings, you can bring in those drawings into SOLIDWORKS Electrical. So let's go ahead and take a look at the schematic. So what I'm going to do, I'm going to go ahead and start with the SOLIDWORKS Electrical 2D. With that platform, it's a schematic drawing tools. You have the option to create a single line diagram, which is more of your conceptual design. So as you see, what I'm showing right now, it's just some 2D symbols showing connectors, showing fans, showing a motherboard. There is a connection, which is my wire, my cables between sub-elements of the same platform. I also have my detailed drawing. So this is more of the electrical engineers. We need to put everything with the details, the wire, the equipotential. We have components information. I want to put in some electrical characteristics. And all of this can be accessed within the, whether you're in a single line diagram or a multi-wire diagram, we can go ahead and access the component properties. This is where I can see the manufacturer information. And then I also can see all the circuits information for that specific part. Harnesses in SOLIDWORKS Electrical are very easy to create. There is a dedicated manager for the harness, and that exists under the project, and then harnesses. I've already took the time to create all my different harnesses and added those to my project. So within the harness, there are several elements that needs to be created. So I have cables, can be wires, can be components. I select those and I add those to my harness. What I'm going to show you, once we go through this, I'm going to come back and we're going to start by creating a component, creating adding the manufacturer information, and then also taking that 3D part and create a complete harness in SOLIDWORKS Electrical. So as you see from my diagram, I'm going to go ahead and switch now to my SOLIDWORKS Electrical 3D. So here's my assembly. As you can see, this is what was represented for the schematic. This is a tower PC. And what you see in yellow, these are just routes that I created to tell the cable where it needs to follow. So when I click on create a route my harness, it's going to follow this route. What I'm going to show you right now to route the harness is I want to route a cable from this connector on the motherboard through these clips here, as you see my yellow, and it's going to come and connect to the connector on the fan. To do that in the 3D space, I'm going to go ahead and hit route harness, and then I'm going to select the harness that I wish to route, which is H5. And that includes, I can also review this information from my 3D, so you can see the true collaboration between the 2D platform and the 3D. Any component that I place, any harness information will be imported to the 3D environment, and you can access this information as well. So I can see my components. These are the components that are a part of the H5 harness. This is the cable that was part of the H5 harness. And when I select the H5 harness to route, it's going to go ahead and route the cable for me, connecting those two connectors. And it's going through its motion. And now here, within few seconds, it completed my route and it created that harness for me. It did follow my path that I created as a guide. So that path that I was showing in yellow, now the cable harness, once it created, it was following the path, going through the clips, and then routed to the opposite side where the H5 exists and where I'm showing the connector on the fan. Perfect, this is awesome. How about the drawing? I'd like to get a drawing of that harness. Very easy. It's simply as a click of a button going to flat the route. I'm going to go ahead and flat the route. It's going to prompt me to save. And before flattening the route, there are two types of flat. I can do an annotation where it's just going to be a true to size. The manufacturer will be the true to size information, and then the annotation kind of compresses everything. So if I have a long route that it needs to be flattened, it puts it in one nice schematic so it doesn't spam over other sheets. So I'm going to use, for me, it was a simple cable routed, so I'm going to use the annotation. I can go ahead and also enable the drawing option if I have a template, so it's going to come up with a bill of material information, my cut list, my connector, and my auto balloons. If you're familiar with the routing of SOLIDWORKS, this is using the same capabilities as the routing of SOLIDWORKS. I'm going to go ahead and hit the green check mark, and as you see, it will generate my cable drawing, and then it generates all the table that I've asked to do. So these are all the table defined in the drawing, and it comes in with information about my cable, about my connector. These are auto balloons that I can reposition anywhere I want, and then it's coming with a true length of that cable. So this is great information. You can see the power of that with just simply few clicks of a button. I was able to wrap my harness and I was able to flatten my harness and get my true length cable information. And I have my reports and my table that all of this information will get transferred back to my electrical 2D. So let me switch to the electrical 2D and then show you the powerful reporting mechanism that we have. So within the reports, we have some predefined reports that you can add to your project. So if I go ahead and click on the add button, these are all predefined reports that I can add to my project and I can go ahead and generate. If you recall my first common design process, it starts with drawing, then auditing, then drawing, then documentation, then auditing. And then this was all the 3 stages. There's some disconnect between those. Now with one tool, there's no more that disconnect. Everything is connected, everything is managed within your project. So I can go ahead and work on my schematic and pass over this information to the mechanical space. And then they can add more components. The components they add in the 3D space, I can see that in the navigator tree, and then I can start adding them to my electrical schematic. I can generate my reports. These are going to be pulling information from the routed cable from the 3D space once it's routed. So what I'm going to do, I'm going to go ahead and click OK, and I'm going to just look at this information that it's been generated for each table. So I can click through, and then you can see that the true length information will be reported when I generate those reports. If you're satisfied with the reportings that you added, all you need to do is generate your drawing. So I'm going to go ahead and hit the Generate Drawing button, and then I can select from those added reports which one I would like to generate. So I'm going to go ahead and enable the first one for bill of materials sorted by mark used in the harness. And I'm going to click on the OK button, and what it will do, it will generate the drawing and add it to my projects tree. So now if I look at my project tree, there is a bill of material. If I double click on it, then I can see it sorted by harness. I can see all the harness information. I can see the connectors that made up of the harness. I can click on and create my list of cables for a specific harness. Like I said, there's plenty of great reports that you can add, or you can even customize your reports to generate the reports that are necessary for your company. What we're going to do now for a starter, I'm going to go ahead and show you how we can create a complete harness in SOLIDWORKS Electrical. I'm going to start in the mechanical space. So what I did is I downloaded, so let me go ahead and open my close out of these. Now, so what I did is I downloaded this connector from the internet, and you see on the left-hand side here, the component is dumb. What I mean by dumb, it doesn't have any extra features that are giving it any intelligence. This is going to make more sense once I start defining my component in the library and add my terminals and circuits. So what I'm going to do, I'm going to switch to the electrical schematic 2D to start defining my component. So what I'm going to do, I'm going to go ahead and add the new part. So I'm going to go to the manufacturer's part. Within the manufacturer's part, what I'm going to do is I'm going to add a new manufacturer, and this is going to be for that connector. So I'm going to give it a name, connector. I'm going to specify a manufacturer. I'm going to just put it under Injy's manufacturer. I'm going to go ahead and give it a class. So it's going to go to my connectors class right there. And then what I'm going to do next, I'm going to switch to the circuits and terminal, and I'm going to add, this is a 3-pin part. So you can see the great techniques of selecting multiple cells and modify them all at once. So within the circuit type, we have all the different types from ground, black boxes, female pin, male pin, and then more circuit types. So I'm going to use this, my terminal, and then now I'm going to define each of those will have a mark. Perfect. I'm going to go back to my property. I'm going to go ahead and select schematic 2D symbol. I'm going to choose the 3-pin connector. I'm going to select that one. And then I'm also going to go to 3D part, and I'm going to choose the connector that I just downloaded. So I made that part intelligent right now. So I created the part, give it a reference. I place it in the manufacturer for Injy in the connectors classification. And then I linked all the metadata that I was talking earlier about. That's for 2D and also the 3D part. I defined my circuit terminal. So this is a 3-pin connector. So I define those as terminal and give it each a circuit. So it means 1 pin for each terminal. I'm going to go ahead and hit the OK button, and I'm going to close out of this. And then now what I'm going to do is once this part is intelligent now in the electrical 2D, I'm also want to make it mechanically intelligent to route all my wires. So I'm going to go ahead and jump to my 3D environment, back to my connector that I just downloaded from the internet. And I'm going to go ahead and start defining, adding some few points. What I'm doing this step, it's not necessary, but it's going to make sense once I start defining the electrical component. So I put in 3 points, and then as you see now, I'm going to go to the electrical component wizard, and this is where it will allow me to define the panel and rack mounted component, also how you auto snap when they are brought into the 3D environment, and then where all the wires will come off the component. So what I'm going to do, I'm going to choose by reference. And this is what I was talking about, because I made my symbol electrically intelligent when I created that. Now I see all the terminal information. However, if that symbol has not been created yet in the electrical environment, I have the access to the same manager through the schematic, through the mechanical space. So again, it doesn't matter who needs to start first, whether you're your electrical guy or the mechanical guy, both have access to the same information. But because as an electrical, I've already done that symbol. So now the mechanical engineer can come in, and this information has been added to the electrical component. So I can go ahead and use that for my solid part. So I'm going to go ahead and define these points. Okay, and you see all the 3 points has been defined. I'm going to go ahead and hit finish. Now you can see what I was talking about earlier when I said the part was dumb, didn't have any extra features that made the part intelligent. Now my part is intelligent, and I can go ahead and click on any of those points, and I look at the parameters information where I can add parameters, sub-length. These are all used in the electrical routing environment. So once the part has been created, I'm going to go ahead and save it. And now I'm going to go ahead and use that part into my electrical schematic. So back to my electrical schematic, what I'm going to do, I can go ahead and insert part like a traditional way. We build the symbol, then we insert the part, or we can do it as a kit. Like I can add the component to my tree and then I can insert them later. Or let the mechanical engineer add them through the components tree because we both share the same component navigation. Once he adds the mechanical part into his tree, it will pop up into my tree as well. So I can go ahead and insert it. So that's what I said, flexibility and then seamless, collaboration between your mechanical and electrical. So what I'm going to do, I'm going to go ahead and add the component first. So I know that I added my connector into my connector classification. So I'm going to go and search for that one. And here's my connector. So I'm going to go ahead. It was added to the Injy. I'm going to go ahead and hit the plus sign. You see the terminal. Everything has been placed properly. Perfect. It looks great. I'm going to go ahead and look at the mark. It's going to assign a designator of P1. I'm going to go ahead and hit the OK button. So now my part shows in my tree. So that's what I was talking about. I can add all the components without inserting them first to my schematic, or the mechanical engineer again can add them to the tree. And because we share that same navigator tree, all the information that he adds into his tree will pop up. So all the mechanical parts that he's inserting to the assembly, it will show up on my tree as well. And at that point, I can go ahead and insert that connector. Excuse me, I'm gonna go ahead and insert symbol. So now the symbol, it's active on my cursor. I'm gonna go ahead and drop it. And then these are all the 3 terminal that has been added to the part. I can come in at any time and look at the component properties. You can look at the mark. You can look at the manufacturer information. Great, I can insert another symbol in the same fashion, or I can select the current symbol and then copy and then paste. And you see with the paste, once I drop it, it automatically increments the designator. So now I'm getting P2, which is incremented. And now I can go ahead and just orient this one inverted so it's looking at P1. So again, very easy whether you insert the symbol, and the SOLIDWORKS Electrical 2D is very intelligent when it comes to symbol insertion. So what I mean by that, if I'm working with a wiring diagram, a multi-schematic wire, it's going to filter all your menus and commands to be specific to allow you to only place multi-wire diagram symbols. If I'm working with more the conceptual level, like a single line diagram, again, it will filter your menus and your commands that will allow you only to place a single line diagram symbol. So, or you can do it from the components tree like I did. What I'm going to do now, I'm going to go ahead and wire that. And I'm going to give it some number. And now that I created my two connectors, they each have a unique designator. I've wired those one and give it numbers. I'm going to create my harness. Very easy to create a harness. All I'm going to do is I'm going to select the 3 component by dragging a route around it. And then on the right click menu, I have the option to create or remove the harness. I'm going to go ahead and add it to the existing H6. H6 harness has been defined as a new harness, but it doesn't have any components or any elements added to it. So I'm going to select H6 and I'm going to go ahead and hit the select button. Now to review my harness, I can go back to the project, harnesses tab, and then I should see my wires added to the harness element and then my component. I'm missing one. So here I can do it one more time. So I'm going to add that part to harness and then I'm going to add it to H6. Now that's why I always like to review my harness to make sure it has the appropriate part. Otherwise, if I was missing a component or I'm missing a cable or wires, when I try to route in the 3D, it wouldn't come. And I'm like, oh, start scratching my head. Why the harness is not routed? Why I don't see it? It's because, you know, I haven't been defining my harnesses, and that's what makes it really hard. So what I will do now, I'm going to go ahead and close. So now this information has been added to the schematic. I'm going to switch to my 3D environment again. And remember what I said, both the mechanical and the electrical, they share the same navigator panel, component navigator. Perfect. Now I see P1 and I see P2. I didn't add those to the assembly, right? Those because the project is linked between your electrical 2D and the mechanical 3D. This information now is available to me as a mechanical engineer through my component navigator. So I can go ahead and now start inserting my symbols. So let me just zoom out a bit and I'm going to go ahead and insert that part. Okay. Let me just go ahead and save that. Let me save my part. And I'm going to come in here and I'm going to load my project. Perfect. And while this loading, I'm going to go ahead and look at my tree here for questions. So I'm going through. So I'm going to read off the question that I received. What about assigning pin to, okay, let me expand this one a bit. What about assigning pin to the connector for What about assigning pins to the connector for the bill of material? Yes, assigning any pins information, once you generate the bill of material, it's all going to be available to you. So let me go ahead and I will show you that in a quick moment here. So I'm just waiting for that to load. Go ahead and show you. Any pins information that you add, you can always come back to your reports and then you generate the reports, and you can include the bill of material. In the bill of material, you can include parts information, but if I understand your question correctly, if you want to import this, if you have pins information from an Excel that you want to import, this is not possible. You cannot import pins information from an Excel. You can import the symbols information. We can import an Excel spreadsheet for manufacturer, but then you will have to define your terminals and circuits. Okay, so let me go ahead and reload my case. Okay, so my part has been my board here. Let me make sure that you guys see my board here. Okay, perfect. So that's my case. I'm gonna go ahead and insert the connector. Here's one right there. I'm gonna go ahead and insert the second connector so I see it from my tree. I'm gonna insert the second connector right there. And then now that it's into the 3D space, you can go ahead and align, you can make those components. I'm gonna just do a quick, rotation so I can see my pins, 1, 2, 3. I'm gonna select that part 2 and I'm gonna rotate it other way. Perfect. This is just a quick, easy way to rotate my part. I'm not making any mating at this point, just so you guys can see it. Let's make sure. I'm gonna rotate it the other side so it mates. So I have 1, 2, 3, perfect, and then 1, 2, 3. So as you see, I'm just doing it very casually here by rotating my part so you both can see both parts, 1, 2, 3, and 1, 2, 3. And then how would I wrap my harness now that it's defined? I'm gonna go back to my electrical 3D and then I'm gonna route the harness. I'm gonna select the harness that I wish to route, so it's H6. Again, I always like to review this data. So I have P1 and I have my wires. Perfect, that's the harness that I wish to route. I'm gonna go ahead and hit the green tick mark. Yep, delete any existing one. And then it's gonna prompt me to save. I'm gonna go ahead and save it. Here you go. And here's my routed harness. Very simple, very quick. And at that point, I can go ahead and flatten it again and then insert it's gonna have my reports, my length, my information. I can come back at any time, update this information, and it will reflect back to my electrical 2D where I generate my reports with a true length information. That takes me to the end of this webinar to show you where Altium stops and SOLIDWORKS Electrical picks it up. I hope you guys enjoyed the webinar. This has been recorded, so you guys give it about 5 to 7 days until we post this onto our YouTube channel. And again, I don't see any questions popping into my screen. So if you have, again, if any questions, feel free to reach out to us through GoEngineer. We'll be glad to assist you with any questions. And you guys have a wonderful day. Thank you very much.